Hello, Earth Science students. This is your Storms and Atmosphere study guide for the quiz that will be open on November 15th and then due before class the following Tuesday. So first things you should know for this quiz is those 4 layers of the atmosphere. So going from the Earth and then moving up, we have the troposphere, stratosphere, mesosphere, and thermosphere. And we've gone over this a lot. So really for this quiz, what I'd like you to focus on is that the troposphere is where the weather happens. We've been talking a lot about weather events, and all of those weather events are pretty much happening within the troposphere. Next, I'd like you to remember a little bit about air pressure. So we talked about air pressure, that is the force that's created by the weight of the air pressing down. And so the air pressure is always weighing down on us, but luckily we have enough force to be able to push back against the air pressure, and that's what allows us movement. If you remember at the demonstration we did in class where we put a sheet of paper over a ruler that was hanging off a desk, and that basically increased the surface area for the air pressure to push down on. So the air pressure was pushing down on the piece of paper, and when we tried to hit the end of the ruler to lift the piece of paper, the air pressure was too great on that piece of paper, and what happened instead was that we ended up snapping the ruler in half because the air pressure pushing down on the paper was too much force for us to be able to lift up the paper with the ruler. Another thing that we've been talking a lot about is this uneven heating of the Earth because of the shape of the Earth, because it's a sphere. So when the radiation from the sun hits the Earth, it hits pretty much at the equator, and that's where it hits most directly. And then the radiation that hits the poles takes longer to reach the poles and is more indirect. It's at an angle more of an angle. And the really important reason for knowing this is because that uneven distribution of heat is what causes convection. So down here is a reminder of what convection is. When we heat up a certain spot, the air will rise, the warm air will rise because the warm air is less dense, and then the warm air will meet up with cooler air higher in the atmosphere, and then it will again sink because when it's cooler air, it's more dense, and that it sinks. And that's what gives us these convection cells, and that's what pretty much gives us wind. So this is another illustration of that, talking about how the warm light air rises and then the cool dense air sinks, and then that cycle is what causes wind, which also has to do with the pressure and density as well as the temperature. On Thursday in class, we talked about these local winds. So one example of a local wind event was a land and sea breeze. And again, just like all wind, it's caused by a difference in temperature. So when we did that experiment where we had the thermometer in the beaker of dirt and the thermometer in the beaker of water, and we looked at which one heated faster and which one cooled faster, we found that land both heated up quicker, absorbed heat faster, and then cooled quicker, so released heat faster. And so in the daytime, when that land warms up really quickly from the sun's radiation, the sea is cooler than land. And so from the land, the warm air rises, meets up with the cool air over the sea, and sinks. And so we get this cycle of the breeze coming from the water onto the land. And when the breeze comes from the water onto the land, that's what's called the sea breeze. And then vice versa at night, when the land cools down quickly, it becomes cooler than the water, than the sea or the ocean. And so the warm air over the water rises, meets with the cool air over the land, sinks, and we get that cycle but in the reverse direction. And when it comes off the land, that's called the land breeze. And just to kind of wrap everything up, this is something we've discussed a lot, the difference between the states of matter, between solid, liquid, and gas. So we can see here the particle arrangement and movement is what's the difference between a solid, liquid, and a gas. So in a solid, the particles are really stuck close together in a definite shape, and they don't move very much, it's just vibrate a little. Whereas in liquid, there is more fluid motion. The molecules can flow and they will fill the shape of the container. Whereas in gas, particles are very hot and they are very fast and they take up all the space of the container. This will do it for the study guide for the storm and atmosphere quiz. I hope you guys learned a lot and are well prepared. Thank you.